Welcome to The Explainer. So, today we're diving into the world of AI, but maybe not in the way you're thinking. We're going to talk about its secret weakness, something you could call its digital disguise. We tend to think of AI as this incredibly brilliant mind, right? It recognizes faces, objects, all in a flash. But what if I told you that all of that intelligence could be completely fooled by something as simple as a sticker? Well, the answer is yes. But look, we're not just talking about putting a blindfold on the AI. Oh no, this is way, way more clever. We're talking about a super sophisticated technique called an adversarial patch. It really is the ultimate digital disguise. All right, so let's get into it. What exactly is this deceptive disguise? We're going to break down the art of this pretty high-tech deception. So forget that whole blindfold idea for a second. It's much more like a clever costume. See, the patch doesn't make an object invisible to an AI, not at all. Instead, it makes the AI look at, say, a person, and with absolute 100% confidence, see a toaster. Yeah, a toaster. That is the real art of digital deception. Okay, to really wrap our heads around this, we have to look at a really core difference in strategy here. We're talking about obstruction versus misdirection. Think about it like this. If you just slap a big black square over a stop sign, well, that's just obstruction. The AI looks at it and basically says, I don't know what that is. It just reports an error. But an adversarial patch, that's totally different. It actually tricks the AI into looking at that exact same stop sign and confidently saying, oh, that's a speed limit 60 sign. See the difference? That's not a failure to see. That's active misdirection. And that right there is the key. The goal isn't to hide, it's to hijack the AI's own logic and force it to come to a very specific and very wrong conclusion. You're not just creating random noise. You're crafting a targeted illusion. Okay, so you're probably wondering, how on earth is this even possible? To figure that out, we've got to take a quick peek inside the AI's mind, so to speak, and see how it perceives the world. And let me tell you, it's very different from how we do. You see, an AI doesn't really see a picture like you and I do. It sees data, a whole bunch of data points. Imagine a huge, massive library, and the AI is the librarian. Over time, it learns to put all the books about cats in one section and all the books about dogs in another. It creates these little zones or clusters for literally everything it can recognize. So normally, when that AI gets an image of a person, it just analyzes the features, the data, and correctly files it away in the person section of its library. Easy. And it's super confident it got it right. But now, here's the trick. That adversarial patch adds very specific, meticulously designed visual data to the image. It's kind of like slapping a fake barcode on that book, a barcode that the librarian is going to associate with a totally different section of the library. And that little fake barcode, it's just enough to completely shift the AI's calculation. The data for the person image gets shoved right across what they call a decision boundary and lands squarely in the toaster section. And the AI, just following its own programming, its own rules, now confidently says, yep, that's a toaster. So that brings up the question, how do you actually make one of these things? It's definitely not just random scribbles on a piece of paper. Nope. It's a super precise engineering process, a blueprint for a perfect digital disguise. It's basically a 5-step mission. First, you have to analyze what the AI is currently seeing. Second, you pick your target. What do you want it to see instead? A toaster? A banana? You choose. Third, you kind of reverse engineer the key visual features of that target class. Then comes step 4, optimization, and this is where it gets crazy. A computer runs thousands, maybe millions of tests to design the perfect visual pattern that will push that image into the new category. And finally, step 5 is blending in. You've got to make sure the patch is subtle enough that it'll actually work in the messy real world. Look, this is a really fascinating technical trick, no doubt about it. But why should we care? Why does this matter? Well, it's because this whole trust illusion thing, it reveals something absolutely critical about the AI systems we're starting to build into our daily lives. And that really is the point. This isn't about creating random chaos. It's about precise, targeted deception. It's almost like a weaponized illusion that takes an AI's own logic and just turns it right back against itself. And that brings us to the core issue, right? This entire technique pulls back the curtain on a fundamental vulnerability in the very systems we're starting to trust with our safety. I'm talking about things like self-driving cars or even medical diagnostic tools. It proves that their perception of reality isn't foolproof. Not even close. It can be manipulated. So all of this leaves us with a pretty big critical question. As we continue to hand over more and more of our world for AI to see and interpret for us, how can we ever be sure we can actually trust what it's seeing? How do we protect our future from something as simple but as incredibly powerful as a digital disguise?